right, so let's do a practice problem. So this says, write the equation for the precipitation reaction between an aqueous solution of potassium carbonate and an aqueous solution of nickel 2 chloride. All right, so I gotta first figure out what is reacting with what. That was step one. What do I have to begin with? So it says, write out the equation for the reaction between an aqueous solution of potassium carbonate. So potassium carbonate is reacting with an aqueous solution of nickel 2 chloride. So that's what's reacting. Potassium carbonate plus my nickel 2 chloride. So I need to figure out what these ions are. So I have to say, okay, well, what's the symbol for potassium? It's a K. And then I look on the periodic table to see what group potassium is in. Potassium is in group 1, so that means he's a +1. Then I go to carbonate. So I notice that it ends in ATE, so that means it's got to be one of my polyatomic ions. So I go to my chart for my polyatomic ions and I find carbonate is CO3 2-. All right, so now I have the charges for those two, the ions. I want to write out my compound, so I cross down and I get K2CO3. Can I reduce that? Nope. And then I want to know what the state is. So it said it was an aqueous solution of potassium carbonate. So that's aqueous. So now I have my first reactant. And who is he going to react with? He's going to react with nickel 2 chloride. So now I need to write the formula for that. So the symbol for nickel is Ni. And it's telling me in Roman numerals right here that he has a +2 charge. Then he's reacting with chloride. It ends in IDE, so that means it's just the element, chlorine. So chlorine is just a Cl. Then I need to know, well, what's the charge on Cl? So he's in group 7, so if he's in group 7, that means he's a -1. Cross down, and I get NiCl2. Can I reduce that? Nope. So now I need to figure out, okay, what's his state? His state is aqueous. All right, so now I have both of my reactants. Now I want to figure out what the products are. So now we want to know, okay, I know what ions are present because I just had to write all the ions out and then I made the formulas. So now I want to determine the formulas of the possible products. So let's see how this works. So for step 2, I'll write out my ions. K+, CO3 2-, Ni+2, Cl-. These are all the ions. So I want to figure out who K+ is going to go with. He already went with this anion, so he wants another anion. He's positive, so he's not going to go with the other positive. So this is what I mean by exchanging ions, kind of doing like a little swappy dance, okay? Like a square dance. So he wants to go with an anion. I've already partnered with him, so now my new dance partner is going to be Cl. And so we always put the cation first, and then we put the anion. So now carbonate wants a new partner. He's already partnered with the K in the reactants, so he's going to partner with the nickel for my products. I put the nickel first because it's always cation, then anion. So then I cross down, and since this is just 1-to-1, I just get KCl. Cross down, I get Ni2, CO3, 2. But since they're both 2's, I can reduce that to get NiCO3. And you can leave the parentheses here if you want, or you can take them away. So now I have my formulas for my products. So now we've determined the formulas of the possible products by exchanging the ions and then just going and crossing down the charges to get the actual formulas. So now we want to determine the solubility. So now I want to know, well, what is the state of this guy and what is the state of that guy? So to do this, I have to use my solubility rules. So I want to pull up my rules, and I want to say the first one was KCl. And so that was K plus and Cl minus. So then I want to look on my chart and see, is anywhere have have a K plus. Whoops. Technical difficulties. There we go. All right, so then I want to say, do I see, and I only look on the left side. I don't look on the right side. Does anywhere do I see K plus? So no here. So K plus is always soluble, and there's no exceptions. So based on the K plus ion, I have soluble. Now I look at the Cl minus. Do I see still a minus? Here it is. So it's always soluble unless it's with one of these. Well, the partner was K. So is this K? Nope. So Cl is always going to be soluble in this case. So you look at both ions and you're going to get the same answer. If you don't get the same answer, that means you read something wrong or did something wrong writing this formula. So now I know that KCl is going to be soluble. All right, what was my other one? My other one was NiCO3. So it's Ni plus 2, CO3, 2 minus for my ions. Okay, so now I want to look up those. Do I see Ni2 plus? Nope. Okay, that's fine. You're not going to find every single one, so I didn't find that one. Do I find CO3 2 minus? Here it is. So it says it's generally insoluble unless it has any of these. So his partner was Ni. So is Ni here? Nope. So if I have CO3, then that means it's insoluble. So the CO3 is telling me he's insoluble. You don't always have to get two answers. As long if you can try to do both so you can kind of check yourself, but not every element, every ion is going to be on this chart. So sometimes one ion is not on the chart, but the other one is. If you ever get a case where both of them is not on the chart, then you read something wrong. You should always have at least one on the chart. If both are on the chart, then they'll give you the same answer. All right, so now I know that my NiCO3 is insoluble and my KCl is soluble. So let's go back. So this was step 3. So step 3 said that the KCl was soluble and the NiCO3 was insoluble. So what that means is, do I do step 4? So step 4 said if you don't have anything, that's a precipitate. So that means if you get, for your products, if you get both of them to be soluble, so that would mean that if both of these were soluble, what you would do is you would write your K2CO3 plus the NiCl2. So say this was number 4. You would write K2CO3 plus NiCl2 goes to no reaction. That's what you would write if both of these were soluble. But that's not the case. So since it's not the case, you just skip this step. Okay? If it was the case, you'd write that and you'd be done. Okay? So if it's no reaction, you just write no reaction and you're done for this part. But if it isn't, then we have to do step 5. And step 5 said, if either is insoluble, write the formulas with their states. And so if it's insoluble, it's a solid. If it's soluble, it's aqueous. So now we're going to say, okay, write out my reactants. KCl is soluble, so if it's soluble, it's aqueous. And NiCO3 was insoluble, so he's a solid. So that's step 5. Step 6 is to balance it. So let's practice our balancing. So what elements do I have on the left? I have a K, a C, an O, an Ni, and a Cl. I have a K, a Cl, an Ni, a C, and an O. All right, how many do I have? I have 2 Ks, 1, because there's like a 1 here, 1 C, 3 O's, 1 Ni, 2 chlorines, 1 K, 1 Cl, 1 Ni, 1 C, 3 O's. So now I need to balance it. So I got to figure out how I want to balance it. So you want to start with anything that's not CH and O. So CH and O we want to do last. and you want to do anything that's not by itself. Well, everything's combined and there's no element by himself, so it doesn't really matter. So we can just start with potassium since he's on the top. So I have 2 on this side and 1 on that side. So which side do I need to put the coefficient to make it higher? That side. So I need to know what do I put here to get 2 total? A 2. So if I put a 2 here, now I have 2 Ks and 2 Cls. Awesome. So now my Ks are good. Then I'll look at my nickels. They're good. My chlorines, they're good. Carbons and oxygens. They're all good. So this would be my final answer. Now I will tell you this, on precipitation reactions, you usually only have to put 1 coefficient, and it's usually like 2 or 3, and that's it, and you're done. So these are really easy to balance, but they're only easy to balance if you wrote the formulas correctly to begin with. All right, so this is writing a precipitation reaction, finding out the products and determining their solubility, and writing out the full reaction. All right, and so you can only do this if you have your solubility rules. Now, the next thing we're going to talk about are different types of equations. I've kind of hinted at this a little bit, but so far we've only really talked about one type of equation. So now we're going to talk about different ways that we can write out equations, and that'll be in the next lecture.